Please hold while your passcode is being verified. Please wait for the tone, then say your name and press the pound key. At the tone, you will be the third caller in the conference. To mute or unmute your line during the call, please press *6 at any time.
Some product selection via a digital I/O, and I will go over some other subject areas as they arise through the slides. First point to consider when looking at digital I/O is how do we get the digital I/O out of the camera? One of the functions, one of the apparatuses that we use is a breakout board. What we have here in this slide is an example of a isolation breakout board. In other words, this part right here with the DIN connector is going to be what connects to the camera, and these are the actual physical I/O 1 through 8, 0 through 7, will be the hard points to connect to. This is called an isolation breakout board in the sense of we can put what are called G4 modules and connect these points to over here, which will be optically isolated using these G4 modules. But what you would need is either a breakout board, or of course there are people out there that will just cut off the DIN connector on the end of the cable and wire it directly into a breakout board. But this is what we'll be using in this class time to access the 8 configurable I/O points, meaning we can configure them either as input or output. When we configure them as inputs, we can trigger them for products, product selections, various other functions, and we'll be doing that through our communications window here, and then selecting what function we want each pin to perform. This can also be done through the outputs also. As you can see, it's the same pins, once again, 1 through 8 or 0 through 7, depending upon how the breakout board is marked. And now those same pins here are configured as output pins. There's another methodology here that I would like to introduce you to, is what's called the inspection results, which this is a part of a Boolean logic where we can AND these together or assign users for these. So right here we have if sensor 1, 2, and 3 are in a pass, pass, fail, these are all AND conditions, then this will do an automatic pass. In this case, it passes, but we're going to be assigning it to user 1, and we can go back in the pins, and we'll show you how to do that. Or in this case, we're just interested in sensor 1 or 2, whether they pass, and then outputting through user 2, which we then can configure in an output capacity through our user outputs right here. We don't have any configured right here, but I can show you how we will do that. The product selection will be a different category, and let me jump out of here just for a second and share this application with you so that we can take a look at it. We'll share an application here. All right, so right at the moment you should be seeing a screen that has an Intellect 1.4, T17, and an IP address associated with it. This is going to be where I'm showing you the different configurations for the physical I/O. There are several ways to get that. One way is going to be down here in communication. Another way would be up here through a system function communication settings also, or directly to digital I/O. I'll try and stay down here in the result table just to keep things familiar for us. So let's open up the communications screen. And here we have something called communications, digital I/O, the different methodologies for communicating outside of the camera. What we're going to be using is the digital I/O. There are 3 categories we'll be reviewing. One is going to be the physical I/O, the Ethernet I/O, and then one to view the I/Os is the virtual. So right now we're going to be working on the physical I/O, so we're going to go ahead and open that. And here are those 8 pins that I was talking about earlier. These are the configurable pins right here. We do not configure them within this screen right here. What we have to do is select one of these, such as this out user 1 here, and go over here to what we call the Properties tab, Under function, here's where our different configurability comes into. We can use these as outputs, as right now I have it as output user 1. I could assign it to output user 2 as it changed over here. But to be consistent, I want to use output user 1. I have other reasons for this. Or we could make this, of course, an input function also, an input users or input trigger, which we already have up here in some product selection. So that's how we go about selecting what the pins will be configured as. It's through this drop-down menu over here in what we call the Properties tab. So I've configured this for output user 1, but when and why does this value right here, this is showing me it's gone high here, when and why does this value go high or low? Go ahead and change this out. Here we've got an out busy signal going here now, and now they've all zeroed, out busy and 0. So we've changed this configuration to 0. So let's take a look at why it went to user. Here we have out user 1. So we're going to have to take a look at a different table. So let's go down here to our results table. Take a look at the inspection results. And the reason why it goes high and low is because right now I'm only looking at the count holes and whether it fails. When it does fail, then it will go high. Notice it's not highlighted right here. All the rest are, they normally default pass conditions. But this one is turned off in this first category, and then in user 1 it is indicating I only want it to go high when it fails. So that's user 1. I have 16 users. As you're going up to user 16, and we'll follow these a little bit later. But notice user 1, when the count holes failed, I want it to go high. So here we are indicating that out user 1, I've assigned it to pin 8. I could assign it to any of these pins. But we're going to assign it to pin 8 right here. I just happen to call it a hold check in the description, which again is something I listed in the Properties tab. But it is going low right now. So in order for it to go high, this category right here, count holes, pass, it has this NA because remember I took it off of the first group, so it is not applicable for that group. We're looking at it as user 1, but it's in a pass condition right now. By putting an object on the image, though, to cover up the hole or indicate that it has flashing in it or whatever, my result table now has a fail in it, and we'll note up here in the values it has changed to a 1. And if you could physically look at the breakout board with me, pin 8 on the breakout board would be also high. So that is how we get these users over here by going to the inspection results table, telling user 1 or using 2. I could actually put this as user 2 as a fail. Oh, I could put it as a fail. So this user 2 now will go high. So I'll say OK to it. And I will change this one here to out user 2 instead of out busy. Out user 2 now. And so when it fails, it also is going high. So that's how you configure those through the inspection results table. And I'm going to go ahead and put this back to out busy. Where it was. And so that is how you configure these through the inspection results table using the users, and to configure the pins using drop-down menus over here in the property sheets right here, property tabs. Okay. Well, let's go ahead then and look at another quick category called product selection. So I'm going to jump back here to our other program. Eventually. And we are going to go to the next subject here. We're just finished up with how to use the inspection results output table to configure our users, and then to go into our actual breakout board communications, physical I/O, and to configure the pins for what we need to have them do. Another area I would like to show you is something called product selection. This is where we have digital IDs under the product manager, product 3, whatever you want to call them here, but they also have something called a digital select ID and number right here. And so these will be automatically assigned, or you can go back in there and reassign them. But what is intended here is, with your lines, we can put product selection on these input lines right here, such as right here we have an input product select. We don't happen to have any product selection bits, but I'll configure that for you in a minute. But what we want to do then is make the selection through what we call product ID bits. When we're talking about bit logic, we're talking about counting from right to left, and the first bit, being the bit 0, will be either 0 or 1. This bit will be either 0 or 2. The second or third bit 2, which is actually the third bit, then it would be 0 and 4. So now for product selections, then when bit 0 goes high, that's the number 1. When the bit 1 here goes high, that's 2. When this one goes high, same as that was before, 2 and 1, this makes 2 plus 1 is product 3. In order to have product 4, though, I would have to have what? A third bit up here, bit 2, or the third bit, which was this one's 0 and 1, this one's 0 and 2, this one would be 0 and 4. So I would actually have to have a third bit in here in order to select product 4 through my physical I/O at this point. What I want to do is go ahead and show you some of those functions, and just briefly what I'll show you in a graphical form here. We have something called the product select input. So it goes high, and it's going to look at, okay, what on bit 0, one on bit 1, what is my signal here? Here it's gone high, so now I've got a 1 on here. Bit 1 has not gone high, so there is 0. The 1 plus 0 is 1, so I would be selecting product ID 1. If this one were to go high, I would be selecting product 2 if this one are low, and product 3 if this one went high, currently with this one up here. And so that would happen there. The next one is, once my product ID has been selected and we have it loaded in the camera, the input trigger will occur right here, and then we will see this signal go high, which means my inspection is occurring during this time. And at the end of my inspection, it goes low, and then it outputs a result for us. So just realize up here we were talking about a product select to get the selected product into the camera, which this one happens to be just product select ID 1, and then occurring with the output here of the inspection results and outputting that data from there. With that in mind, let's take a look then. I'm going to go back and share this application again with you. And let's take a look now at how to do a product select. These happen to be product select is what will instigate the camera to look at what product IDs are active. Right now we have 0 products selected. In order to discover what you want to use for an ID, you're going to have to look in the product manager up here. And right now I only have 2 products in here. One is called the gasket demo, the other one is port check, which happens to be product select ID 2. So in order to select this, then I would have to create bit 0 or bit 1. Actually, bit 1 go high and bit 0 be low, and select this product. So let's go ahead and take a look at how to do that. So I could physically connect to the camera right here and select a bit right here. Bit 0 is low. This one right here. I'm going to use a technique in this camera rather than physically go over there so that you can see it. I'll do it here on this. I'm going to force this bit to high. So that's bit 1. So this is 0 or 1. This one will be 0 or 2. And I am going to go ahead and, as you see, we got all these sensors on our go plus that one right here. I'll take that off. Go ahead and trigger that so everything's passing on that one. There we go. And go ahead and show you up here we have gasket demo in our product box, but I want to select the port check. So in order to do that, I will have to send this pin product select high, which is pin 2. So let me go ahead and I can manually do that over here. And as you see, in product select bit went high. I'm removing the 24 volts to that pin. And we have up here in our product box port check, which is a different product file for it. So now we're looking at a different, we're just looking at the internal port of this gasket, verifying that it is working or not working also. And so thus as we go through here, we can say, well, yes, it is working. If I cover it up or use some sort of material in here to cause it to fail, we also have a fail here. We'll notice in the inspection results, we don't have anything assigned to user 1. This is just what it defaults to right here under this first category. So that is working for us there. To show you briefly what happens to some of these functions, I'll use this one here to show us in the virtual I/O what is occurring. So let's go ahead back to communications. Digital I/O, or virtual I/O. Now these are going to show you representatives of all the configurable pins, all the configurations you can have for these. Notice we have here trigger, reserve, event, digitals, reserve, product ID bits right here. You'll notice what this is. This is product ID bit is 1. That's because in that breakout board configuration, I forced that bit high. And if we look down here below, we have user 1 inputs, and input 2 is low because I'm not physically bringing that high. And if we look at output user 1, remember I had that other one go high for us before when the gasket failed, but right now it is not going high at all because it is passing and I haven't assigned it anything. If I go down here in my inspection results and go ahead and make this one a fail, we'll do it like we did before. I only want user 1 to go high when it fails. Obviously, has it failed yet? No. Oh, yes, it has. So let's go here and do that. And notice now I can see that user 1 has gone high. And this is a way to look at all the pin configuration possibilities that you have and exactly see what is going on with that configuration right there. So this is our virtual I/O, gives us an immediate bird's eye view of everything in the camera that is occurring with it. And so that is that function right there, the virtual I/O. Another category I'd like to just jump back and show you. We had the physical I/O, virtual I/O, and then we have what is called, load this up for you, something we call the CON IOE. What this is enabling you to connect to the camera over the Ethernet with I/O function points right here. These are physical I/O right here also. This configuration over here, remember the breakout board I showed you earlier had a DIN connector on it. This is a DIN connector, and these points right here are your 8 points. 1, 2, down here, 3, 4, 5, 6, 7, and 8, and then this is power for it right here. So this is actually another configuration for a breakout board for the camera called CON-BRK. This is same thing as the iBob, except the iBob is an isolation breakout board. This one does not offer isolation. But what this does offer you is a more modular configuration for what we call our Ethernet I/O right over here. So what you'll notice here is we do have an Ethernet connection to connect to this, and then we can gain 8 more. This is going to be power for these modules. So we have here 1, 2, 3, 4, 5, 6, 7, 8 in output. And again, the same thing over here with our input. So we're going to gain 8 more input and output. And not only that, we can start ganging these, so just not 8 more outputs. We could have 16 outputs and 8 inputs, however you want to configure those. So this allows you more hard contact points for your camera through the Ethernet I/O. And where you will find that inner function is right here in the communications again. We'll go back here to digital I/O, and this is our Ethernet I/O. We've discussed virtual, started with physical, and here's the Ethernet I/O. Let's open this up. Now you will notice when we're on the Ethernet I/O over here, in the properties box right here, we have something called a MAC address right here and an IP address. That's because we have on the Kind IOE an Ethernet connection, so we're going to have to know its MAC address, which comes listed with that Kind IOE. There's a white tag on the very front of it, which will give you its MAC address, and you can assign an IP address to it and a mask, and then enable that, and that will be able to connect you with through the Ethernet to your camera, which then will become functional for you. We have here 0 through 8 input and 0, 1 through 8 output, which is the configuration I showed you on the Con IOE that last slide. So this again is going to look very similar to what we've done before. As you see right here, we have our the input 1 here is disable run mode. Here's our functions. We have a whole host of configurability for these pins also as inputs. These are only inputs right here, and these are only outputs. So they are not both input and output. You either have an input, 8 input, or 8 outputs. But within each category, there are many areas to be able to select what you want that pin to be able to do. I do not currently have a Con IOE hooked up to this to show you this, but this is the basic function here. You have to configure this Con IOE first, connect it to the network so it can see it, and then come over here and assign the pins. As you can see, we have lots of ability now to do some product selections over here to enhance the number of product selections that we have. There is one other area I would like to cover it with you, just briefly to show you that it does exist, is we do have something called scripting. If you'll see over here with our physical I/O, when we configured some of these functions right here, outputs, you'll notice we have some output scripts right here. So we can actually have an output script function happening here also. What that means is I can go through here and configure this using our scripting editor to command some outputs and inputs. So let's take a look how to do that. I'm going to jump back here to my gaskets demo. Here I happen to have a script written already for this, just doing it simple, and we'll show you here in a second. This is a script tool. And what I'm doing is I'm just sending a bit 48 and 49 to activate script 1 and script 2, which, as you saw in my I/O functions, I could assign script 1 to a pin. Or, in other words, what this is generally used for is to be mapping towards a PLC or from a PLC. So how this is going to work is what this does is this holds script 1 and script 2 high for 10. I actually changed it to 1 second so that we could see it. So let's see how that acts. We're going to go ahead and say, okay, so this is scripting. So this would be used, I only want these to go active if such and such a case happens. So many of these other sensors pass, I want these to go high, and that would be an if-then logic or if-else logic that you would script in there. So we take a look at these functions right here. Again, to be able to view what script 1 and script 2 do, I don't need to look here. I can go over here to the virtual I/O function and go down here and take a look at where the scripts are. And we have users and we have our scripts right here. So this is my digital output 49, which we'll talk about mapping in a second. We're looking at script 1 and script 2. They should go high when I trigger this, and they do go high for about a second, and then they cancel. One thing to note, all these things are outputted from the camera via a running mode or inspect mode. If this inspect mode is not active, we're not going to be able to communicate outside the camera. So realize I'm triggering right now. The scripts are working within the program, but they are not outputting from the camera. In order to have that, I must have this button Inspect on. And then when I trigger this, it's going to go through the whole result table and the script and output the results. So as we can see, script 1 and script 2 are going high right there. Okay? What this means is I can script these functions and also write these to registers. In order to write these to registers, I need to know how to map those. These are found under a different function, which is found in our script reference manual. Okay, it's loaded. Let's see if I can share that with you. All right, there you go. You should be able to view that now. This is called our script reference manual. And what I'm going to do is just show you briefly where the sections are. There should be a section here on I.O. I usually know where they are by mapping them. But use of I.O. commands right here, the I.O. functions. Right here, input-output functions. And what I'm looking for is the map right here. As you'll notice, I'm looking at virtual I.O. right here. This is in the script reference manual, and we were using script 1 and 2. If you look here, we have script 1 over here and script 2 right here. It's in register 1. Over here in register 1, bit 0, bit 2, bit 3, bit 4. There are 8-bit registers. It's in register 1. To be able to view that, I need to take a look at the registers in the camera. In order to take a look at the registers in the camera, I have to jump back there. But before I do that, just to let you know about this I.O. mapping function, here you'll notice we have busy, fail, pass, product ID bits. These are the pins, I.O. 1 through 8. And these also are writing to register. This is happening to writing to register 5, 6, and 7 here, this bit over here. And down here in the trigger usually is your input 1 is register 23. Bit 0, product select, which you and I just used a minute ago, is in register 23, bit 0, or I'm sorry, bit 1. And up here on bit 21 were those product ID bits that we just took a look at. So realize these are all mapped here also. So we're just going to take a look and see what happens to register 1 in bit 0 and 1. So let's take a look at what that's going to do. So let's jump back here and just a second. Go ahead and close that out. Share the application again with you. So script 1 and script 2, let's make sure they're still working on. Yes, they are. They're turning high right here. So script 1 and script 2. But I need to take a look at the registers to see what the registers are doing. Well, again, we're in communications, and we can take a look here at DVT registers. If I look here at DVT registers, here we've got register 101. Let's go ahead up here to register 1 is where I told you the information was getting recorded to on bit 0 and bit 1. So as we activate this, we'll see this turns to a 3. The reason why it turns to a 3 is because bit 0 is 1, which is high, and bit 0 is 1, and bit 1 is 0 or 2, which goes high. So that means 2 plus 1 is 3. So in that register, we are holding a 3. In order to let you see how that number changes, let's take a look at the script. I will change the script slightly. Okay. By taking out this right here. Okay. So let's go ahead then and see how that going to result with our bit logic right here. It changed to a 1. So I'm just reading script 1 right now at the moment. If I had deleted the other one, I would see just the number 2 here. So that was what's held in register 1 of those bits. So that about covers it for the communications with digital I/O. Under this digital I/O function here, we have the physical I/O, which is where we can work and configure these functions right here. There are some other functions to realize with this. We have some bounce times and some filter times in here. But the main function I want to make sure we are covered with are the different functions that we can configure each one of the pins, and to make sure that we have the inspect button on. Otherwise, these will not update for us. Well, that concludes digital I/O and a little bit beyond. But if you have any questions, please call us at 770-814-7920 and ask for tech support. We'll be glad to cover any of your questions. And next week we will have another online session at 2 o'clock, and we look forward to seeing you there. Thank you very much, and have a great day.